Hi, this is on Lesson 5, Decimal Points in Products. So we're going to take a look at products that are decimals. 5.1 multiplying by 10. Question 1. In which equation is the value of x the largest? So what times 10 gives me 810? So I know that anything times 10 is going to basically add a place value to the end, so I know this is going to be 81. What times 10 is 81? Well, 10 times 8 is 80, so 10 times 8.1 is 81. What times 10 is 8.1? Well, I know it's going to be less than this, and it looks like it's the same value here, so .81. And then here, I'm going to go along with the same pattern here, is I'm going to move the decimal one place over again and get 81 thousandths. So for the first one, 81, the second one, 8 1/10, the third one, 81 hundredths, and the fourth one was 81 thousandths. So which one gave us the largest x value? This first one. How many times the size of 0.81 is 810? So it is 1, 2, 3 times as big. And look, 1, 2, 3 times as big. So there is times 10 times 10 times 10. So 0.81 times 10 times 10 times 10 gives me 810. 10 times 10 times 10 is 1,000. So it's 1,000 times larger. .2 Fractionally speaking, powers of 10. So working with a partner to answer the following questions, one person should answer the questions labeled partner A and the other should answer those labeled partner B. Then compare the results. Because I'm not going to be in class, we're just going to do it individually. Find each product or quotient. Be prepared to explain your reasoning. So we're going to do column A and then we'll do column B. We'll compare and then we'll answer some questions down here. So 250 times 1/10. So 250, I'm going to put this over 1 and use my fraction information from last unit. So it's 250 over 10. So really that's 250 divided by 10. And I'm just going to take off those zeros and I get 25. So 250 now becomes 25. All right, 250 over 100. Because again, I just multiplied across. 250 times 1 is 250. 1 times 100 is 100. 250 divided by 100, so 100 goes into 250 2 times, and then with the 5 left over. So it gives me 2.5. So because I divided by 10, my place value went down by 1. I divided by 100, so my place value went down by 2. 48 divided by 10. You can do, if you want to do long division, you can. 10 goes into 48 4 times. Ten goes into 8 times, so then I get 4.8. So just another method of how to do this. And then here, 48 divided by 100, or I can write it as 48 hundredths. And 48 hundredths is written as 0.48. So just another method. I could have done long division. I just wrote it in fractional form. And then for fractional form, I can write it in decimal form. So it looks like, again, if I divide by 10, my place value moves once. If I divide by 100, my place value moves twice. So just a nice little thing that we're noticing. All right, over here, 250 divided by 10 can be rewritten as 250 divided by 10. 10 can go into 250 25 times. 250 divided by 100, that's the same that I got over here, and that gives me 2.5. So it looks like we're getting the same answers that we did partner A to partner B. 48 times 1/10 can be rewritten as 48 over 10. 10 can go in 48 4 times, and then 8 out of 10 is 8/10. 48 times 100 is 48 out of 100, and 48 out of 100 is 48 hundredths as a decimal. So again, when you divide by 10, you move the decimal once. You divide by 100, you move the decimal twice. You multiply by 1/10, you move the decimal once. You multiply by 1/100th, you move the decimal twice. So it looks like dividing by 10 is the same as multiplying by 1/10. Remember how dividing by numbers is the same as multiplying by the reciprocal. Dividing by 100 is the same as multiplying by 1/100th, because dividing is the same as multiplying by the reciprocal. Okay, so those are the relationships. So then we're going to use our work in our previous problems to find 720 times 1/10 and 720 times 1/100th. Explain your reasoning. So 720 times 0.1, or we can rewrite it as 720 times 1/10. Well, what was our rule? We multiply by 1/10 or divide by 10. We move the decimal one place over, so we know we're going to get 72. And what did we do? We moved decimal place one value. All right, 720 times 1/100th, or 720 times 1/100th. Well, remember up here when we divided by 100 or multiply by 1/100th, we move the decimal twice. Once, twice, once, twice. So we're going to do the same thing here. So 720 once, twice, and you get 7.2. So hopefully you're seeing the relationship that, and we can write this down. When you multiply by 1/10, decimal place value gets smaller by 1. So you scoot the decimal one place to the left, like so. Oh, I'm sorry, you didn't see that. Here you go. So when you multiply by 1/10, the decimal, comma, decimal place value gets smaller by 1. So you move the decimal place over by 1. So example, 34 times 1/10 is now 3.4, because it moves one place over. And then every time you multiply, so if you do a 10th, you move once. You do a 100th, it's twice. You move a 1,000th, it's 3 times. All right, now they're going to want us to do the products on the other side. All right, so let's use the rule that we just came up with. So 36 times 0.1 is, well, we're multiplying by a 10th, so that means I moved the decimal one place to the left, so you get 3.6. All right, this is, here, let's write this down. This is 1/10. This is 54 times 1/100th. So 1/100th. This means move once. This one means move twice. Okay, so now we have 54, but we're dividing by 100, so divide by 10, divide by 100, so then you get 54 hundredths. All right, 24.5 times 1/10. That means to move it once. So then we're going to take our 24.5 and we're going to take our decimal, we're going to move it once, and we get 2.45. So our place value went smaller by by one place value. All right, 9.2 times 1/100th. So we know 1/100th is moving it twice because 100 is 10 times 10. So then we have 9.2. We're going to move it once, twice. And this is different because there's no number here. So what number do you put here? You put a 0. So our answer is decimal 0.92. So 92 thousandths. 1.8 times 1/10. You get 1.8 times 1/10. 1/10 we know means to move once. So 1.8, move it once, and you get 0.18. And I'm putting a 0 there in the ones place value. So I didn't here, but you can. So you can do both ways. Sometimes I put a 0, sometimes I don't. It just, I don't know, it depends on the problem, I guess. All right, question 4. Jada says if you multiply a number by 1/1000th, the decimal point of the number moves 3 places to the left. Do you agree with her statement? Explain your reasoning. So if 0.1 means to move 1 left, and then 0.01 means to move 2 left, then to keep the pattern going, 0.001 means to move 3 left. So when Jada says if you multiply a number by 0.1/1000th, the decimal point of the number moves 3 places to the left, she is correct. So you do agree. And we showed that right here. All right. 5.3, fractionally speaking, multiples of powers of 10. So question 1 says select all expressions that are equivalent to 6/10 times 5/10. Be prepared to explain your reasoning. So first of all, we probably need to figure out what this is. And what we're going to get is that you have 0.6 times, basically you have half of 0.6, and half of 0.6 is 0.3 or 0.30. So we want to know of these, which ones will give you the same answer as that. So 6 times 0.1 is 0.6, and 5 times 0.1 is 0.5, and this one is good. So that's a good one. 6 times 1/100th, no, that's not the right number, so that can't be it. That one's good, but that one's not. 6 times 1/10, yes. 5 times 1/10, yes. So that actually does work. 6 times 1/1000th, no, and no. 6 times 1/1000th times 5 times 1/100th, no. 6 times 5 times 1/10 times 1/10. Well, because this one is true, we have the commutative property, and commutative property allows us to organize it where we can put any number, them in any order. So 6 and 5 can actually be switched and put together. So you can put 6 times 5 and then times 1/10 and then times 1/10. So this actually works out. And then 0.6 is 6/10, and so that's good. And then 0.5 is 5/10, which is good, and so those work out as well. So A, C, F, and G are all true. Find the value of 0.6 times 0.5. So we actually already found it here, but we can show different reasonings. So if we do it this way, 6/10 times 5/10, you get 30/100ths, which equals 0.30. But in 5th grade, your teacher probably told you that you don't need the 0 here, so you can write it as just 0.3 or 3/10. Okay. Question 3 then says, find the value of each product by writing the reasoning with an equivalent expression with fractions. So 3.03 is 3/10 times, this is 200ths. And then now we're going to multiply. So 3 times 2 is 6. And then 10 times 100 is 1,000. And 6/1000th is 0.006 as a decimal form. So here's the fraction form and here's the decimal form. All right, 0.07 is actually 7/10 times 0.05 is 5/100. So similar to this question, we're going to multiply across. 7 times 5 is 35. 10 times 100 is 1,000. And then we can rewrite this as a decimal. .035, or that. Okay. All right, so that's it for your lesson 5. So if you'll go ahead and read the lesson summary, they just talk about how using fractions is similar to using your decimal values as 0.1, 0.100, 0.1 or 0.01, that they all can be rewritten in fraction form since we just finished our fractions. And then if you'll please complete your lesson 5 practice problems, and then the answer key is on my website. All right, I hope you guys have a great afternoon. If you have any questions, please ask Miss Ashley or Miss Hartman. If you definitely need to ask today, if you can wait, I will see you guys back on January the 3rd. So I hope you guys have a great afternoon, and I'll talk to you later.